Hello everyone, and welcome to the solution for the string compression interview problem. So the problem was this. Given a string in the form, such as this, a bunch of letters, you need to compress it to become this, the letter and then the number of times it occurred. For this problem, you could have falsely compressed strings of single or double letters. So for instance, a string AAB, it's okay if it returns A2, B1. Even though this technically takes more space with 4 elements instead of 3 elements in that string. The function should also be case sensitive, so that 3 capital A, 3 lowercase a returns this, A capital A3, lowercase a3. Okay, so let's think about the solution. Since Python strings are immutable, we'll need to work off of a list of characters, and at the end, convert that list back into a string with a join statement. The solution below, the one we're going to go through, should yield us with time and space complexity of order n, where n is the number of elements in that string. So let's go ahead and take a look. Pay careful attention to the comments here if you're just going to go through the notebook, but we're going to actually code this out and explain what we're doing along the way. So let's go ahead and begin. We're going to start by creating our compress function, and it takes in a string s. The solution is actually known as compressing without checking, and it's called the run length compression algorithm. So this one actually has a name already. We're going to begin a run as an empty string. So I'm going to make a variable called r for our run and compare it or set it equal to an empty string. I'm going to make a variable called l and set it equal to the length of our string. And let's go ahead and do 2 edge cases. First edge case is if we have a length 0 string. Second edge case is for a length 1. So I'm going to say if L is equal to 0, then just return an empty string. If L is equal to length 1, then return the string, which is going to be just one letter, plus the number 1. So for instance, if our string was just a single letter A, we would return A1. So again, we're not actually compressing in that case, but this is just okay since we're just doing a run length. Now let's do the meat of the algorithm. So in order to do that, I actually need to initialize some values. I'm going to make a value called last and set it equal to the first element of the string. Then I'm going to make a value called CNT, which stands for count. That's also going to be equal to 1. And then I, which is going to be an index marker, I'm going to set that equal to 1 as well. So I'm going to say while I is less than L, the length of that list, what I'm going to do is say if S of I, so the element at that index of the string, if it's equal to the one that came before it, so what this basically means is if the letter at I is equal to the letter before it, let's go ahead and add a count. So I'll add it to that count. Else, that means they're no longer in continuous series, so we're just going to store the previous data. I'm going to say r is now equal to r plus s at I minus 1 plus the count. But we'll need to convert this into a string since we're just putting this string together as the run. Once we've done that, we'll just go ahead and add to the index to continue on throughout the entire string until we've terminated that while loop. After that, we're just going to put everything back into run. So I'm going to say r is then equal to r plus at the previous plus strcnt. And then I'm going to return r. So let's go ahead and see if this works. Okay, we'll go ahead and run compress. Let's put a string AAB, see what we output. A2, B2. So we have an error here. What's going on? The reason for that error is because we need to reset the count after we've redefined R. So I need to put in CNT here equal to 1. And now if we run it, you'll notice we get the correct result, A2, B1. Let's try it on some more examples. Here I have 4 C's, so I should get A2, B1, C4. We have A2, B1, C4. If I pass it on AAB, A2, B1, we're still good there. Let's see if it does lowercase. Good. Capital A, lowercase a, too. All right, so that's it. Let's go ahead and go over this run length compression algorithm one more time. So what are we doing here? We're just setting this run equal to an empty string, L equal to a length of S, checking our edge cases, initializing some variables. In this case, sometimes people use last as a marker. We didn't actually use it, but just keep that in mind. Some people tend to use that. We'll also put in a while loop. So what's the while loop doing? This is the heart of the algorithm. We're saying while this index is less than the length of the string, if the string at that index is equal to the index before it, so that means if that element is equal to the element before it, we go ahead and add a count. Otherwise, we build out this section of the run, which is going to be R. In this case, if you look at what we set R equal to, an empty string. So on the first run, that's just an empty string plus that very last previous element plus the string of the count. So all these counts added together, convert it to a string, and then we reset the count. Once we did that, we went ahead and added 1 to the I, and then we're back at the while loop until we're no longer less than the length of the string. And then finally, we add all the R's together in the same fashion we did it up here. Then we just return that run. Okay, that's it for this solution. Go ahead and go over the full notebook if you want every step explained as a comment, but that's basically it. All right, thanks everyone, and I'll see you at the next lecture.